Hi guys, it's Mrs. Tucker. This is a review of multiple representations and functions. This is all from the Region 4 algebra book on multiple representations. So let's get started. Everyone's got their review in front of them. We have a lot of people absent today, so we're going to do this together. Alrighty, the first question says, which graph does this table go with? I've got a set of x values, I've got a set of y values, and I have, actually I just have two graphs here, okay? I want you guys to figure out which graph goes with this table. I would just plot the points. -1, -2. -1, -2 is right here. Does that fall on the line? No, let's try it on the next one. -1, -2 falls right there. Definitely falls on B. Let's try one more. What about 2, 0? 2, 0 is right there. Which graph are you going to choose? B. Yep, graph B. That's pretty easy. You guys have done that before. Okay, is it a function? Now you guys, I'm not going to go over my little analogy. Remember the kind of racy analogy I used in class? I'm going to say it this way. Every x value only gets one y value if it's a function. Any set of ordered pairs is a relation, but not all relations are functions. Every x only gets paired with one y. Take a look at this table. You know, you could pretend like this table's a mapping diagram if you do this. And then you could draw your little arrows. 0 goes with -7, 1 goes with -5, 2 goes with -3, 3 goes with -1, and 4 goes with, I don't know, some number. If you looked at that mapping diagram, does each x go with only one y? Yes. Is it a function? Yes, that one is a function. Yes. Take a look at number 4. What do you think on that one? If I turned number 4 into a mapping diagram, I'd only list each number once. So I would list, in the x column, I'd list 0, 4, and 16. And in the y column, I'd list -4, -2, 0, 2, and 4. And when I drew my arrows, it would look like this. 0 goes to 0, 4 goes to -2, and 4 also goes to +2. 16 goes to -4, and 16 goes to +4. Do you see how this x value is being paired with two y values? That is not allowed in a function. You can only have one arrow coming out of each one of these x values. Is this a function?
No.
No. It is a relation, but it's not a function. In a table, if you have an x value that shows up twice, it is not a function. All right, let's look at number 5. Look at number 5. Is it a function or is it not a function?
Yes.
Does each x value only show up once?
Yes.
Then it's a function. Take a look at table number 6.
No.
Is that one a function?
No.
Why not?
4 shows up twice.
Yeah, the 4 shows up twice. It is a relation. It is a set of ordered pairs, but it's not a function. That x value can only show up once. All right, let's keep going. I've got mapping diagrams this time. Look at number 7. From a mapping diagram, you can tell if it's a function if there's only one arrow coming out of each one of your x values. Is number 7 a function? Yes. Is number 8 a function?
Yes.
Yes, good for you. Even though y has all of these arrows coming at it, the only thing that matters is your x value, and there's only one arrow coming out of each x value. That is a function. Good for you. I tried to trick you on that one. What about number 9? Is it a function?
No.
Why not? Yeah, that's the reason why it's not a function. By the way, what's another name for your x values? Domain. What's another name for your y values? Yeah, good for you. Okay, let's look at 10 and 11. Is 10 a function?
Yes.
But I got two lines coming to the 8. You're right, it doesn't matter. It's the only the x values that matter. So yes, that is a function. What about 11? No, why not? That's right. You can't have those two. 5 is being paired with 2 and 9, and that's not allowed with a function. It is a relation, though, but not a function. Okay. I have shown you guys how to tell if it's a function from a table, from a mapping diagram. Now let's look at graphs. If I give you a graph, you do the vertical line test. If I draw a vertical line, if it is a function, it only passes through the graph once. But here, this passes through the graph twice. So this value of 3 right here, x value of 3, is paired with this y value of 1.5, and it's also paired with a y value of about negative 1.5. Is it a function? No. Your x values can only show up once. Take a look at 13. I'm going to do the vertical line test. Each time I draw a vertical line, it can only touch the graph once for it to be a function. Is this a function? Yes. That's a function. Yes, it is. Your algebra teachers are going to be so impressed. 14 is a vertical line. Is a vertical line a function? If I draw a vertical line on my vertical line, doesn't my vertical line cross the graph at all of these points? Yeah, it is not a function. Vertical lines are not functions. Think you can remember that for the test?
Yes.
Okay, what if I had a graph that looked like this? No, not yet. What if I have a graph that looks like this? Is that a function? But it passes the vertical line test right here. It passes the vertical line test here. It passes the vertical line test here. What about here? Yeah, let me try to get it in there better. What about right there? No. That's the reason this one would be a no. Because right here, this vertical line right here would not pass the vertical line test. Good for you. All right, number 15. Write the ordered pairs for the graph below. Write the ordered pairs. Ordered pairs have a set of parentheses and a comma in between. You're already done. Uh, 1 comma 4. 2 comma what? What's this point right here? No, 2 comma 1. This point is what? 2 comma 1, 2, 3, yep. What about that point? 3 comma 1, 2, 3, 4, 5. What about that point right there? 4 comma 1, 2, 3, 4, 5, 6, yep. And one more point. This one right here. 1, 2, 3, 4, 5, 6, 6 comma what? 6 comma what? Thank you. Thank you. Number 16 says, is the relation shown above in number 15 a function? You say it's not a function, why not? Jason says it doesn't pass the vertical line test. Do you guys agree with him? And if you looked at the ordered pairs, why else would you say it's not a function? Excellent, excellent. The 6's don't matter. It's these two 2's right here that make it not a function. Good for you. Excellent. All right, let's go look at 17. 17 says, state the domain and the range of the relation shown in the table. Use set notation. Set notation is just those funky little curly brackets that are so hard to make. And when you list them this way, if there's any numbers that repeat, you don't repeat them. And usually we put them in numerical order. In our domain, which one's our domain, the X's or the Y's? The X's, yeah. We're going to list them in numerical order. Which one's our smallest number? Negative 2 is our smallest. Then what? 0, then what? 2, then? Okay. And none of those repeated, did they? On our Y, usually they list them in numerical order. Which one's our smallest? Negative 1, then? Then? 11. Okay. Is it a function?
Yes.
It didn't ask, but yes, it's a function. Okay, let's go do number 18 next. A water tank that holds 550 gallons of water is draining at a rate of 20 gallons per minute. The function f of x, have we talked about this crazy thing called f of x?
Yes.
F of x is just a fancy name for what? Y. F of x means y. So anytime you see that, like right here, if you don't like f of x, just write y. It means the same thing. The function f of x equals 550 minus 20x gives the amount of water in the pool after x minutes. Complete the table below. You know how to do this, don't you? Yeah, you do. Do you see the equation in your process? Guess what goes all the way down the front? 550, 550, 550. Then what's going to come next? Minus, 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 minus. Then what comes next? 20, 20, 20, 20. 20 next to x means we're going to do what? Multiply by what? Your x values, yeah. All right, give me some answers. 550, subtract 20 times 0. 550. Okay. 2 times 20 is what?
40.
That's 40. What's 550? Subtract 40. 510. All right. I have 550, subtract 20 times 4. 20 times 4 is 80. What's 550? Subtract 80. Yes, sir? Because what's 20 times 0? 20 times 0 is 0. Yeah, so you're taking 550 and you're subtracting 0. Good question. Yeah, good question. 550 subtract 80 gives you what? 470. And then the next one. 550 subtract 7 times 20 gives you
390, 490, 450.
I got what? I got 410. Here's a little side question. If you graph this, would the slope be positive or negative? Yeah, good for you. Slope is negative. Good for you. Because as your x values are increasing, your y values are decreasing. Good for you. All right, I'm about to run out of time here, so I'm going to start number 19 in the next video. Okay, so about, I don't know, an hour's gone by since I made the first part of the video, and I can't remember if we did 19 or not. So I'm going to pick up with number 19, just in case we didn't do it. I can't remember. It says, graph the ordered pairs generated by the graph y equals 5 minus 2x if the domain is -1, 0, 1, 2, and 3. What's domain again? Yep, those are all of your x values. So let's create a little xy table of ordered pairs, and then we can graph it, x and y. And the equation is your y equals 5 minus 2 times your x value. All right? So our first x value we're going to pop in is -1. That's what they tell us our domain is. -1, 0, 1, 2, and 3. So let's put in a -1 here. If you add a line and change the sign, that's a -2. We're adding a -2. Orders of operation says you have to multiply before you add or subtract. What's -2 multiplied by -1? -2 times -1 is +2. So this turns out to be 5 plus 2, which gives you 7. So let's graph that. -1, -1, 7, -1, 1, 2, 3, 4, 5, 6, 7, right there. The next value for our domain is 0. Orders of operation says multiply before you subtract. 2 times 0 is 0. 5 subtract 0. Yeah, that's going to be a 5. 0, 5, right here. 1, 2, 3, 4, 5. Then we're going to put in 1 for our x. 2 times 1 is 2. What's 5 subtract 2? Well, 5 subtract 2 is 3. So 1, 1, 2, 3. The next value of x is 2. 2 times 2 is 4. What is 5 subtract 4? Yeah, that's going to be 1. So 2, 1, and then we're going to put in a 3. What is 2 times 3? Yeah, that's 6. What's 5 subtract 6? -1. So 3, 1, 2, 3, -1, and there's your graph. All right? And because they gave us individual points to graph, we call this discrete, and we would not connect the graph, or we would not connect the dots here. Not in this case. All right, number 20 says, which axis do you always graph the dependent variable on? Well, if you looked at my big cheat sheet on the wall, the dependent variable always goes on the what axis? Yeah, the y-axis. Independent variable always goes on the x. All right, let's go on to the next page. Okay, birdseed is sold in 5-pound bags. Sketch a graph to show the total weight of birdseed purchased by a customer who buys 0, 1, 2, 3, or 4 bags. All right, I'm going to make myself a little table here. And this is going to be bags. And this is going to be total weight. 0 bags, 1 bag, 2 bags, 3 bags, 4 bags. Birdseed is sold in 5-pound bags. If I don't buy any bags, I don't have any weight. If I buy 1 bag at 5 pounds per bag, I have 5 pounds. 1, 5 is about there. If I buy 2 bags and they're 5 pounds each, I've got 10 pounds. 2, 10 is about here. If I buy 3 bags, that's 15 pounds. 3, 15 is there. If I buy 4 bags, whoops, I'm sorry. If I buy 4 bags, that's at 5 pounds a bag, that's 20. So 4, 20 is about right there. All right. Why? Oh, the question is, would you connect the dots here? Why or why not? All right. Well, you're going to ask yourself a question. Right here, will they sell you 1.5 bags of birdseed? If the answer is yes, connect the dots. If the answer is no, you don't. Can you go to the store and buy 1.5 bags of birdseed? No. So you would not connect the dots. Why or why not? Because they won't sell you a part of a bag. And that's what you're going to say, because they won't sell you part of a bag. 22. The table shows the number of hours of sleep versus math test scores. Draw a scatter plot and trend line. Okay, I got to decide which one am I going to graph on my x-axis and which one's going to graph on my y-axis. Well, the dependent variable always goes on the y-axis. So does your test scores depend upon the hours of sleep you get, or does the hours of sleep you get depend upon your test scores? I'm going to say my test scores depend upon how many hours of sleep I get. So test scores is dependent. Hours of sleep is my independent. We're going to start here at 0. And hours of sleep looks like it goes up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of these is going to increase by 1 hour each time. Okay, so there's 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, 8 hours, 9 hours, 10 hours. And test scores have to go all the way up to 100. Let's see, there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Each one of your lines here has to increase by the same amount each time, so I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I'm going to call this test scores. Give it a title. All right, start graphing the data. You graph the data and I'll graph the data. Then we'll see what kind of scatter plot we get. So go ahead and pause the video. I'm going to do that myself. Let's graph the data. Pause the video. Let's see, 993 is about here. 888 is about there. 991 is about there. 1076 is about there. 778 is about here. And 8,100 is about here. Okay, I've got all of my scatter plot data drawn. They want you to draw a trend line. Sometimes a trend line is called a line of best fit. So what you need to do is you're going to draw a straight line as close to the center of this data as you can. And so I'm going to kind of do something like this, I think, so that it looks like the more hours that you sleep, the better your test scores get. Now you can make any kind of predictions. And I don't know, is the next question a prediction? Let me see. Oh yes, based on the trend line, predict the test score for a student who got 3 hours of sleep. What's your prediction? My prediction for a student who got 3 hours of sleep, here is the 3-hour line. It crosses the trend line at this point here. So if you go over to here, I'm going to predict their test score is about a 52. That's my prediction. Score is approximately equal to 52%. That's how you use scatter plots and trend lines to make predictions. And folks in business do this all the time. If I were to ask you the red line, is that a positive trend, negative trend, no trend? What would you call that? Look at the slope of the line. Yeah, we would call this a positive trend line or a positive correlation. Some people call it a correlation. Positive correlation. Write that down and I'll know you watched your video. Okay? All right, let's look at 23. 23 says, oh, sorry I don't have an answer bank put together, but I do have you a video, so there you go. 23, which mapping best represents the function y equals, this is x squared plus x minus 3. Y equals, you're going to take your x values and square it, then add x to it, and then subtract 3 from the answer. So I'm going to go ahead and build myself a little table. And let's see, I see a negative 3. I'll put in a negative 3 for an x. What other values do you see for x? I see 0. I see positive 3. Let's see, if you put in a negative 3 right here and square it, that says what's negative 3 times negative 3? Negative 3 times negative 3 is positive 9. 9 plus, well, what's our x value here? Our x value is negative 3, and then we're going to subtract 3. So 9 plus negative 3, that's 6, and 6 subtract 3 is 3. So I know I need to have the ordered pair negative 3 comma 3. And that doesn't match up, does it? That's negative 3 comma 0. I know that one doesn't work. Let's put in another number here. Let's put in 0. 0 times 0 is 0, and 0 plus 0 is still 0, and 0 subtract 3 is negative 3. So I need 0 comma negative 3. That works. I can't see C. I'm going to try putting in a 2. So right here I'm going to put in 2. Let's put in a 2. 2 squared. Well, I'm also going to put in 2 right there. 2 times 2 is 4. 4 plus another 2 is 6. And 6 subtract 3 is 3. Whoops, that was for 2. 2 goes with 3. That works out. What if you put in 5? Let's put in 5 here. If I put in 5, and I put in a 5 right here, 5 times 5 is 25. 25 plus another 5 is 30. And 30 subtract 3 is 27. Well, it works out here. The 27 works, but 5, if you plug in 5, you never get a 9. So that one doesn't work out. So which mapping diagram is going to go with this one? Let me scroll down a little bit. Yeah, it looks like it's going to be C. C is your answer. Did you pick C? That's what I got. C is the answer here. All right. Am I recording? Oh, yes, I am. Okay, I didn't see my little time there. Okay, one more thing you got to do is Big Spender. Big Spender says, Randy has $240 in his savings account. He is spending $15 per week. Create a table, a graph, and equation to represent the balance in his savings account. Okay, at week 0, he opens up his savings account, and how much does he have in his savings account at week 0? $240. Okay, he is spending $15 a week. So at the end of the first week, he has how much money in his account? If we removed $15 from it, he's got $225 in his savings account. At the end of the second week, he's removed a total of 30 from the 240, so he's got 210. And as our x's increase by 1 each time, what's happening with our y's? Yeah, they're decreasing by 15. So that's your hint in your process. That's the first number that goes in here. All right? And then I told you guys your little hint is the next thing you're going to do is multiply by what? Yep, your x values. And does negative 15 times 2 equal 210? No, you're going to have to add or subtract an adjustment. Negative 15 times 0 is 0, but they say the answer is 240. What do you have to add on to 0 to change it to 240? I hope it's the same number you're adding on here and here. All right? And before this video ends, I want to talk about how you're going to set up your graph. Don't forget to give your graph a title. Here, does the number of weeks depend upon the balance, or does the balance in your savings account depend upon the number of weeks? Your balance goes here, and weeks goes down here. 0, 0. Good luck.